Hello, everybody. Welcome to the Lsvr working group session this morning. So we have about 90 minutes to go. We have a reasonable agenda today. We have a little bit of slack time, but it really depends upon how the discussions actually go during the sessions itself. So to kick off with, first on the administrivia. So we have a Jabber scrap. Victor is going to take the honors, unless there is somebody else in the audience willing to look at the Jabber thing. So many volunteers. Then the minutes is like another moment to actually glare at your screen. Any volunteers for minutes? Okay. So we have thank you, Nabil. So we have 2 people to look in the minutes. So Niraj and Nabil, thank you for that. So it will be on Etherpad. If you would like to contribute, feel free to actually open it up and type in, and help typing up for the minutes. So that's very appreciated. So the next thing is the note well. If this is the first time you see the note well this week, not really sure you have been attending IETF a lot during the week either, so you've probably been exploring, Prague too much. So it generally says that, whatever you say and do over here, it's going to be part of the contributions of IETF, but, and you know this. So if you want to know more about it, just read this thing. So from a next steps perspective, so where are we from the Lsvr deliverables? So we started about a year ago. We are now a year into our time frame here, and the initial plan actually was to have most of the drafts and ready for submitting and so onwards. We're going to discuss later on where we are at this point in time from the draft perspective. Originally we also were planned to actually have another interim meeting. Now, we didn't really do that because just after the new year, it was a little bit, tricky with everybody's agenda. Now, at the same time, we also did a working group last call on the main draft, and that actually required some work. So I think the interim actually was not really justified to do it at that point in time. So the agenda for today, we actually have 4 main topics. From what you will see. So first we're going to be, getting an update on where we are from the LSOE perspective. So what actually changed in the latest draft and some other updates. Then the second topic we're going to be talking about here is a use case of the LSOE technology. It's not really associated to what Lsvr is exactly about, but because it is actually a technology using LSOE, and because LSVR is actually adopted in this working group, it's interesting to actually have some awareness of what actually is happening there. So that's going to be 50 minutes, and I'm going to, the plan is to keep it to 50 minutes and not longer. Then the next topic we're going to be discussing is the synchronization with the IEEE. So I'm going to be mentioning it later on also in the working group here. So we have sent a liaison towards the IEEE regarding the LSOE technology, and to let them know about it. And the IEEE has received that well, and they have sent us a response back on their perception of what actually is happening here. And then at the end, we are going to be discussing the latest updates about the Lsvr, BGP, SPF, and Keuro AC is going to delivering the presentation. So that is the agenda. Alvaro.
Hi, Alvaro Retana. Just to clarify, that point where Paul is listed as speaking, those are 2 separate points.
Sorry, say again?
Right there, we were talking about the liaison.
Mm-hmm.
You said liaison, LDP V2 proposal, update, Paul as the speaker. Those are 2 separate items, or they're the same item?
So looking at so he's going to be discussing from looking at the slides, he's going to be discussing the liaison response, a very short overview of what actually it is, and he will also discussing what the LDP V2 technology is about. Correct, Paul?
Correct.
Okay. So any further agenda bashing, or we're all happy? Everybody's smiling, amazing. Yes, Kier.
Kier Patel. If you go back a slide, I just wanted to call out that the Yang model work is underway. Some of us have been focusing on the implementation, obviously, and as part of that, we've been trying to define. So if there's anybody who's working also independently, would happy to work with them.
Okay, yeah, because it's one of the deliverables, and right now it's not in orange state anymore. It's more like in the red state. Thank you. This is where we are from respect of the milestones and the deliverables. So we have most of the work ready. The Yang is what Keyur actually mentioned. So it's actually in process of being created. Now, when we started a year ago, we actually were not thinking about LSOE as part of the LSVR working group, but in the meantime, we did like a call for adoption, and the work actually got adopted into this working group here. So we actually have this now as a working group document, because it is really, a technology like that is, key for, for our link state vector routing to behave in a correct way. So another thing what happened since the last IETF is we did like a working group last call for BGP SPF technology, the BGP SPF draft. That actually runs from the 3rd to the 17th of December. And a number of good feedback actually were received on that one. And if you look into the working group list itself, that has been the key discussion items actually, during on the working group email list itself, which is a little bit which was good for the progress of this particular document. And based upon all that feedback, a new document actually has been progressed, and we actually are processing the LSVR draft itself. From the LSV's perspective, there actually was a working group adoption call done, and we actually got it adopted on the 24th of December. Another thing actually happened is we have been contributing in creating a liaison towards the IEEE regarding the link state of Ethernet, because in essence, we actually are fiddling with layer 2 technology here. And because, from an historical standardization perspective, that has been mainly, part of the IEEE activities. So it was required, maybe required is a strong word, it's like it's actually a good thing to let them know that we are working on this, and that there is like no misunderstanding. So we shipped that one out on the 10th of January. The IEEE actually has received that, and that actually triggered them to reinvestigate what LLDP actually is about, and look into potential ways of extending it and creating like a next revision of the technology, taking into account some of the properties that technology like link state vector router actually requires. So the liaison response is actually on the IEEE workgroup page, and I think very soon it will also be on the IETF site itself also.
So, AC Linda, I was waiting for a good time. I read that response, and I was thinking, if we reach an impasse here, couldn't we just put a 20 byte header with a multicast address in it and terminate the discussion and keep the protocol intact?
What do you say if you go to an impasse? We're not there yet, so.
I know, but I read the response. That's what.
The response was out of two, there were like two elements to it. One element is like, the name is confusing, so that is the easy thing to fix. Yeah. The second element actually was like, mainly like, this is layer 2 technology, and maybe, it would be more interesting to just extend LLDP, into the next version.
Exactly.
And avoid that the industry actually has like 2 technologies. And actually,
that's what I'm saying. It might be easier just to get a local wire multicast address from the IETF and put the 20 byte header in there.
Alvaro, just a quick comment. The formal liaison did come in yesterday.
Yes, yesterday night, yeah.
Just to respond to John Scudder, to AC's comment, I sort of had the more negative reading of the liaison that AC did. And whether from that you conclude that you should like do a little process workaround by slapping on a multicast header, that's another question. I mean, I'm not sure if I had been the person who wrote that liaison, if adding a multicast header would make me be like, oh, okay, that's fine then, no problem. I mean, it is a technical workaround, but it's not a workaround for a technical problem, so I'm not sure if that's really addresses it.
Randy Bush, Arcus, and IIJ. Just so everybody knows, Paul and I collude with each other. I don't pay attention to the liaison stuff, but he has been very helpful in LSOE, and I've tried to help with LLDP V2. So let's not create unnecessary conflict here.
Correct. Yes, that's what I was alluding to.
Sorry, John Scudder, to add one more thing. Yeah, it would actually be a perfectly fine outcome from my point of view to have one, as long as it solves everyone's problems. I mean, that's kind of what the liaison said, and you know, great, as long as we can have it.
Yes, I agree. And actually, part of the journey is that we have Paul volunteered to give an update on where we are with the with the LLTP V2 proposal itself, and understand the timelines and some of the other aspects involved. So that's going to be discussed about today also. So this is like a very short summary of what the the liaison was about, but it's going to be in Paul's deck also. So I'm going to be skipping it for the moment here in the sake of time. So that's it from the chairs to kick it off here. Unless there is any other comment, then we're going to go to the first slot here to talk about the updates about LSOE itself by Randy. Okay.
Hi, Randy Bush, IJ and Arcus. I know it's crowded in here. There's room down front if you need it. That was a joke here. Okay. They've given you some of the history. This is just going to be an update. You are expected to have been tracking the draft. Okay. I just want to thank some of the people who are here. John gave a number of excellent reviews. Rob, of course, Niraj. Larry Krieger back at Arcus waxed layer 2 clue into me regularly. Paul Congdon's been very helpful, and others. It's now a significantly more mature draft, I think. Let's remember the goal here, okay? We're trying to do link layer topology discovery and liveness for the control plane of Lsvr. Okay, that's the goal. Just a reminder of an overview of the protocol. Okay, it's conversation happening at layer 2 to push the discovery of these interfaces up to BGP SPF, who then builds the topology and the address mapping, etc. Okay? So you've read the draft, of course. So I'm going to talk about what's new. The first thing is surprising, and you'll get to hear from it. Niraj has extended it already, which if you are an IETF traditionalist, you know that's actually a good sign when you get surprised by somebody extending your protocol. He's using it for EVPN, discovery instead of endless ARP snooping. And I needed this to get the cat pictures in. Okay, so what are the details? The new version have clearly delineated a transport layer of frames that can be used to build very large PDUs and a state machine over that transport. So you can take Ethernet frames and build large LSOE PDUs. Okay? Currently it's 64 octet, 1 is the limit. That could be raised if anybody has need for more. Be good to say it now before we bake 64K in. Niraj is already being very piggy, but I don't think you're going to hit 64K, are you, Niraj? You're not going to hit 64K. Okay, oops.
K. Patel Arcus, but this should be good enough to help support some of the configuration information as part of the discovery that would need to be carried.
Yeah. So, okay. There's duplicate frame detection at the transport layer, duplicate PDU detection at the upper layer. There's retransmission on timeouts, etc. There's also a vendor extension PDU. Okay, so you can add your flavor. Okay. There's the explicit ACK and error. The ACK, if the E-type and error code are non-zero, it's an actual error, tells you what the error was, gives you a hint, etc. Okay. Before, we were looking at, do we merge hello and keep alive? Are they both necessary? The current position of the authors is yes. Hello is multicast, so you can discover across a layer 2 device. Okay, and the hello has 2 types of frames. One is the one that will actually transit a layer 2 device. The other is not. Okay, but hello's multicast. Keep alive is unicast because it's actually keep alive on the link. Okay, and you probably want very separate timers for them, right? You want to discover your topology. Maybe you're willing to put up with multi-second discovery delays, whereas keep alive, you may want on the order of a second or less. Okay, look at the lessons we learned in BFD. Okay, so if anybody would like to try to adjust my attitude on merging the two, I'm more than willing to listen. Okay. Still open is, do we add a signature to each PDU? In other words, we could very easily have cryptographically verifiable authenticity and integrity checking. We had data center operators who said they wanted it. When I asked what their threat model was, the line went dead. Right? So if anybody here wants to talk to me about the authenticity and integrity requirements they have, I would love to hear it. 2/3 of the authors have some experience in doing this kind of thing. We know how we would probably add it. But the customer has to say they want it. Okay? A shocking thing happened to me on the way to the meeting. I was brought up, my mother always told me that Macs are unique in the universe. Well, it turns out they're not. As one of my friends says, Cisco and IEEE have spent the last couple of decades making things complex. So currently, the identity of a link is the 2 Macs. Larry Krieger has educated me that it probably needs to be the 2 Macs and the VLAN ID. I would gladly accept more education on that. For instance, Russ has tried to tell me it's just one of the Macs and the VLAN ID. But I think that's more on a layer 2 device, and we're having links between layer 3 devices. Okay, but there's clearly a problem here. We'll go forward. So John asked for a state machine. I'm sorry, John, the state machine is not in the current draft. Rob wrote one in Python 3 instead. It's about the same length as the spec, except it has more blank lines and it has comments. If you want a denotational semantics instead, I know how to do that if you want it. Okay. And the good news, though it's a predictive piece of news, is that we're waiting for Kayer's okay to open source it. Okay.
Keyur Patel-Arcus, again, this will happen shortly right after IETF. Hopefully in this year.
He's my boss. I take his promises with a grain of salt. But it is, when you get to see it, it's the state machine, John. You'll like it. Okay? The draft, of course, needs review. Okay? Prefer to get some volunteer reviewers without having to working group last call it in order to get your attention. So, folk with eye on it would be helpful. And that's all I have. Due to other constraints, I have to streak back to family problems in the States, so I'm going to leave here. So please head for the mics now.
John Scudder, thank you. I'm glad to know the source is the documentation. Always sort of a mixed message, but snark aside, I have a question, and it's really a question about what you said about security. You said the users have to ask for it, and I'm not the user, so I'm not really here asking for it, but often what I hear in the IETF is we do security unless the users tell us not to.
No, I didn't say that. I said they have to tell me what their threat model is so I can make sure the security beats that threat model.
Okay, that's actually, as the words were coming out of my mouth, I realized that I was making the common error of conflating a crypto hash with security. That's sort of like saying, oh, I put TLS on it, and that's the same as securing it. So yeah, right. Shame on me. But nonetheless,
if you want security, you can use IPsec, right?
Nonetheless, I do hope that more people in the group other than just you and me are going to have this conversation because I think it's important.
I would gladly put it in. I just want to make sure I'm putting the right stuff in.
Rob Osstein, Arcus, one of the co-authors. All joking aside, essentially what we've gotten at this point as far as security is our threat model is that somebody told us we need to have security. We don't know what that means, but we need it. That's as far as it's gotten. You can't design from that, so that's why we're waiting for input.
I even suggested some aspects of the threat model. In other words, somebody walking in and plugging into your class or so on and so forth, and nobody rose to the bait. It has its privileges.
Okay, I'll go over that. So if or as this moves forward, please make sure that you put in the document the assumptions about security. If we say we don't need it or we don't have it right now, we need to clearly specify why. So if we're assuming that this is in a closed domain, no one's going to walk in, and the worst thing that can happen is, as you said, I actually walk physically into the thing, please talk about that. Because that way it's a way to justify the lack or the fact that we don't have it right now.
I think the SecCons does that. But I will be laughed out of every coffee house in Prague if I go for working group last call with a SecCons that says we don't do it.
The other thing that may be nice is if we go and request Security Directorate review beforehand so that we don't have last minute surprises, and maybe that will be justification.
That would be helpful.
Victor Coursing, hat off, user on. We can I'll supply some more information on the list, but probably one way to look at it, and I can iconify this statement, is that no devices are trusted in a lot of fabrics. So the assumption is that you cannot trust anything that connects to you, and that there has to be ways to secure that and validate that is in fact a trusted device. I'm not sure that helps, but I can supply more text around that if you like.
Are you willing to do let's make believe you're a class. Are you willing to do a CA for your class and have every device have an identity?
I would suggest that's highly likely that that's how it works often, yes.
Cool. We know how to do that. Ladies and gentlemen. I got the design now.
Okay, then maybe one question. You can, yeah, just, your last slide, you actually were mentioning that you were looking for volunteers for like reviewing the work, correct? I'm going to ask the question on the list also, like, is there like anybody in the room here, like, willing to sort of like stick up their hands and actually, provide a review of the latest LSOE document? Nabil, Sean? Okay, I will ask the question on the list also, but already thank you. Thank you.
So, John Messenger, I would encourage you to liaise with IEEE 802.1 and use Layer 2 mechanisms defined in IEEE, because we're the guys who know how to do Layer 2. Thank you.
Okay, thank you. Hirash, yeah.
Good morning, Neeraj Malhotra, Arcus. I am going to be talking about LSOE-based PEC control plane for EVPN networks. So the main use case for this is an EVPN IRB network, where today CE MACs and IPs are learned on the PE interface, on the PE access interface, and advertised in an overlay BGP EVPN control plane to the other PEs to establish both routed and bridged reachability across the CE devices. So as it stands today, there isn't a dedicated PEC control plane in an EVPN network to do so. So as a result of that, CE MAC learning is done based on traditional data plane MAC learning. CE IP learning is done based on ARP and ND snooping. And for scenarios where the CE might have prefixes behind it, but does not actually run a dedicated PEC routing protocol, these prefixes are advertised from the PE device based on local policy configuration. So as a result of this current learning method, the CE MAC learning today, following scenarios such as a host move or following convergence triggers, is very tightly coupled with how often the CE is sending data traffic at that point in time. And the CE IP learning at the same time is very tightly coupled or heavily dependent on receiving unsolicited ARP and ND packets from the CE device. And when the CE is multi-homed to multiple PEs, this learning is also subject to the fact, or each PE must also handle the fact that these data plane, ARP, and ND packets, as well as the data traffic packets, can hash on any of the member links of the lag and can arrive at any of the PE devices. So what is proposed in this draft is a PEC control plane option, such that PEC MAC learning or the CE MAC learning is fully decoupled from data traffic received from the CE, and CE IP learning is fully decoupled from ARP and ND packets received from the CE. And the goal of this being to essentially, following convergence events and following host move events, to have a very reliable and consistent convergence behavior, and at the same time, significantly simplify some of the procedures that are currently in place to handle these convergence scenarios, especially when you have EVPN all-active multi-homing in the picture. So a quick overview, the control plane is essentially based on LSOE as the base protocol. And on top of that defines procedures and TLVs for overlay MAC learning, for overlay host IP learning, and overlay prefix learning. It defines procedures and handling with respect to when you have EVPN all-active multi-homing for the CE devices, and discusses the use cases that can benefit from this optional control plane. So it's fairly straightforward in terms of the mechanics of it. It's mostly riding on top of LSOE. So the PE device establishes an LSOE session to the CE device on the PE attachment circuit. Overlay TLVs for MAC learning, MAC to IP binding, or rather IP to MAC binding learning, and prefix learning is sent from the CE device and learned on the PEs, and advertised further in EVPN control plane. And then you have session liveliness maintained via LSOE keep alives. When the CE is multi-homed to multiple PE device, and it could be more than 2 devices, it's just shown here with 2 devices, a separate LSOE session is established to each of the multi-homing PEs. And this is really important because it now gives each PE the ability to learn its entire state directly from the CE without having to rely on the other PE devices. And this brings significant simplification to our multi-homing implementations from handling perspective. Because now you no longer have to sync the MAC tables across the PE devices. You no longer have to sync the ARP-ND tables across the devices. And the PE devices no longer have to handle unsolicited ARPs coming from the CE device, as opposed to in the current scenario, an ARP request could be sent from PE2 to the CE and the response could land at PE1, which must handle this unsolicited response. In addition, because of that non-deterministic behavior as to which PEs might learn the MAC or the MAC IPs, today we have procedures like EVPN aliasing to accomplish ECMP paths for MAC forwarding. And that again becomes optional once you have natively learning the MACs and IPs on each PE device. The other complexity is for IP ECMP, typically today the implementations sync the MAC IP route to the other PEs, and then the other PE typically will re-originate that MAC IP route as its own to accomplish IP ECMP, because, and that's essentially kind of, I mean, there are some proposals for IP aliasing in place, but that's the current implementation in the absence of an IP aliasing procedure. When a host moves, today, when a host moves, the only way to detect a host move is when you receive the first data packet from that host. If the host is silent for an extended period of time, you would continue to black hole traffic to the previous location of that MAC until the MAC ages out at the old PE location of that MAC. And once the MAC ages out, if the host is still silent, you would continue to flood the traffic on the overlay until you've actually learned the MAC at the new location. So just to take a closer look and appreciate the actual complexity involved today with respect to handling a host move. Essentially, when you receive the first packet from the host, that packet triggers the host move event in hardware, and typically it will be sent as a packet punt to the CPU or sent as a MAC move event to the CPU. Once the software learns of that MAC move event, doesn't necessarily guarantee that you would have also learned the IP to MAC binding at the new location of that host, because you may not have received a gratuitous ARP from the CE at that point. So based on that mismatch between a remote MAC IP entry and a local MAC entry, the PE will typically trigger an ARP probe to the CE. And the probe reply could, because of the multi-homing, could easily land at the other PE, which would then advertise, which would then handle this unsolicited ARP reply or ND response and trigger a MAC IP advertisement in BGP control plane, as well as sync that MAC and IP to the other PE. And that other PE device, on receiving the sync entry to accomplish IP ECMP, will typically again re-originate that MAC IP route as its own route to the other PE. When the other PE's receive these MAC IP advertisement, the old PE where this MAC was originally local will trigger a probe again locally. The probe that will fail and typically age out, and you would have convergence following the host move. As opposed to that, with LSOE, it's fairly kind of simplified, right? Pretty much the host moves, establishes an LSOE session, sends its TLVs. The TLVs are learned and advertised in EVPN control plane, received by the other PEs, and you have convergence. So another use case for this is remote MAC IP routes learned via BGP EVPN overlay control plane can also be preemptively relayed to the local CE, essentially to establish preemptive ARP learning on the CE, essentially like an ARP suppression mechanism. For scenarios where the CE has prefixes behind it, but doesn't run a routing protocol on the PEC interface, today advertisements for those prefixes behind the CE gateway are based on local policy configuration on the PE device. So again, this local configuration overhead can be replaced with sending these overlay prefix TLVs via LSOE from the CE to the PE device. So in summary, basically two main sort of goals that I would want to highlight for this is one, essentially trying to achieve a very deterministic and reliable convergence behavior across all convergence triggers and host moves. At the same time, significantly simplifying some of the procedures and implementation related to these, to the respective handling, especially in case of an EVPN multi-homing scenario. So that's basically.
AC Lindum, I think this is a really good simplification, and it really makes things more active rather than passive in the whole thing. The only problem with it is it brings these CE devices. You could never get rid of the old, the passive way and the learning way of doing it, because it brings them into the EVPN, and getting those devices updated with this, and even if it's open source, so many times that's going to be just administratively impossible.
Yeah, sure. So, I mean, one thing I would want to kind of highlight is that it is an optional PEC control plane and not a replacement for the current learning method. And it's totally intended to coexist with other C devices in the same network that may not be using this control plane. So it's basically, it can be used where the C device has support for it, but the goal is to have it interwork with other C devices that don't have support for it.
Robert Raszuk, Bloomberg. So I have a question just to clarify. I care less about MAC learning. Okay, so I want to have L3 learning, which you show on the slide. So is the goal here to use this kind of LSOE for L3 prefix learning as the only application in some cases? Can I use it that way?
You should be able to, right? Like, I mean, basically, so all the TLVs are optional. Essentially, you can, if the C is sending MAC and IP TLVs, you would use them for MAC learning or host IP learning. So the routing application, again, can be based on prefix routing, or it can be host routing, right? Like if you have truly an overlay subnet stretch, then you need to have host routing. So essentially, then you would use the host routing TLVs or the /32 or /128 TLVs as well. Otherwise, yeah, you could simply use if you have the other use case of, the CE being the gateway, first hop gateway for prefixes behind it, and you want to advertise those prefixes with the CE as the gateway, then you could use it essentially for just the prefix learning TLVs.
Okay, do you have any traction in Kubernetes communities or any other outside of, IETF with this kind of proposal? Are you proposing it there to make it more real?
Not yet. I mean, nothing, no progress on that front yet.
Hi, Paul Congdon. I wonder if you have, or maybe could provide in some future contribution, a more kind of concise description of the requirements of a protocol to support your needs. what exactly is needed out of the protocol in terms of, maybe timeliness, message sizes, responsive, various attributes like that. Because it strikes me what you did was you said, here, we've got a tool, LSOE, how do I use it, right? And I'm wondering if we could take the reverse look and try to analyze, well, what other solutions might be there or could be there to optimize your requirements?
Yeah, no, certainly very good point. Actually, we should take a closer look at sort of like what might be the timing requirements, for example, for keep alive messages and so forth.
Yeah, Sharkash, I have a question actually. I guess in service provider deployments, C and P devices support LLDP. Have you studied with respect to the MAC addresses, what can or cannot be achieved with the current standard LLDP?
Sorry, with LLDP, did you say? Or
802.1 AB, link layer discovery protocol.
Okay. So basically, so the main reason for kind of picking LSOE to do or to achieve this was kind of a couple of attributes of LSOE. One, it being session and connection oriented, and being able to carry very large TLVs in it. I mean, I personally haven't taken a closer look. I mean, maybe Keyur can comment.
Perhaps it would be good to take a look.
Yeah, Keyur Patel Arcus. I think the answer to your question lies in the fact that when you deploy a technology like EVPNs, neither ARP nor LLDP comes into the play there. You do more of this kind of resolutions that Neeraj was talking about from the data path learning. And the data path learning is not deterministic. It has convergence impact and it adds a lot of complexity to the software, which hopefully Neeraj tried to articulate it pretty well up here. And that sort of complexity can be easily replaced if you have a connection-oriented protocol that does an implicit announcements and not a periodic refresh. That was the point.
Okay, thank you.
Randy Bush, I just want to apologize. I'm not leaving because of your presentation, Paul, but I've got medical stuff back home, and I have a flight that departs in 2 hours.
No worries. Take care of that. Yeah. Okay, hi, I'm Paul Congdon. I'm doing a couple things here, as mentioned. Just giving a summary of the liaison discussion, as well as presenting a current status of an LLDP LLDP version 2, so to speak, proposal. And I guess one thing I want to point out is on that proposal, we're just, that's just an example of how things we could do that match the current LLDP requirements or use cases, as well as trying to address LSVR's use cases. There's nothing set in stone here. It's very fluid, so things could be adapted as needed technically. So just as a disclaimer, I'm an individual here, as we all are, but I need to show the fact that I'm just giving you my position or representation of the liaison. There's an official one that goes on. That's not me. And so these links were I think many of these links were already shown as discussed. There was a liaison sent from the IETF to the IEEE, basically giving background about LSOE and asking for comment, and there was a reply that was sent. So my personal summary, kind of what the response from IEEE is that we're aware of this work. I've been coming here and reporting back and forth, and many people from IEEE come to IETF as well. So we're aware of the work that's going on. The first thing kind of came up was potential concern about the confusion with a link state over Ethernet protocol that we've standardized called shortest path bridging. So shortest path bridging is actually a topology management protocol, ISIS, using link state to manage it. And we didn't believe LSOE is actually a link state protocol. It's in support of a link state protocol. So the naming itself was a little confusing. So I think it's possibly very obvious. But one of the main objectives of LSOE was to provide, as Randy mentioned, link layer discovery and as well as liveness. And so as we all know, we have a very widely deployed popular link layer protocol. It was also link layer discovery protocol. And it's also understood that the current definition of that protocol may not meet the needs of LSVR. And so we've been entertaining proposals to augment LLDP for many use cases, not just LSVR, but in intention to try to support those or some of those. One of the particular use cases, liveness requirement, personally, I didn't believe is suitable for the LLDP as it's done today philosophically, because it's as Kara mentioned, it's more or less a state refresh, not a highly responsive kind of protocol. That doesn't imply that couldn't be changed to be more of that. We do, however, have other standardized layer 2 protocols like connectivity fault management, CFM, and others that actually do support liveness, and there may be other ways in which liveness could be supported. So I think that was sort of also a consensus of the 802 group. And then finally, of course, we want to collaborate and work on this as well. And so we welcome work in the IEEE to do that. Care?
Yeah, sure. Thanks. Keyur Patel Arcus. There are a bunch of requirements. We'd be happy to work with you on that. A lot of those requirements are being covered as part of LSOE proposal, but like I said, happy to collaborate. Thank you.
Okay, so again, I'm gonna provide a background of what we're currently proposing to do to LLDP, and again, it's very fluid. And it's open. We haven't even started a project. IEEE did agree to draft a project proposal and address the requirements to start such an amendment project. So that's in the early stages. And so a couple of us have already put forth something, and there's a contribution that was made at IEEE as well that tried to compare how this proposed idea would meet the requirements of LSVR that Randy had put together in some previous contribution for the IETF. And then we discussed next steps, where we did agree to consider drafting a proposal. So just as a quick summary side, I looked at the requirements. Oh, go ahead, Alvaro.
Sorry, before you go, if you go back to the last one, just so that we understand a little bit of the IEEE process. Okay, there's a proposal. So what happens? I mean, we understand when proposals happen in the IETF, what happens, but what happens in the IEEE?
Great. Okay, so the IEEE actually drafts what we call a PAR, which is a project authorization proposal that defines the scope and purpose and of a project, and then we get approval through the higher layers of the IEEE to actually run a project, and that project, depending on how it's defined, would either amend an existing standard. So the proposal would be that we would take LLDP and add some new chapters, make changes, whatever, to address the new requirements. Or that project could create an entirely new protocol. That hasn't been decided yet. But there's a project authorization that starts a working group, a work in a task group within 802.1.
So that discussion of whether that PAR is approved is going to be in March.
Well, in March, we agreed to jointly draft a proposal and submit it to the IEEE. We haven't agreed on what the contents of that are. We just authorized our working group to actually generate that project proposal. Yeah, Janos, go ahead and clarify.
Janos Farkas. So just to elaborate a bit more on this. The first point I would like to make clear that IEEE 802 is contribution driven, same as IETF. Participation is in individual basis, same as IETF. Anyone can come and contribute any part of this work. So the next step, what is happening, so this past plenary, we have authorized the forthcoming May interim to specify the project specification, the project authorization request. So the wording of the group who would be the host of the project 802.1 will be done and finalized in the May interim. There can be discussions up to that point, and in the interim, we can have discussions on the weekly TSN calls. Is it to request an agenda item? We can discuss these topics in preparation for that meeting, and the PAR text will be crafted at the May interim face-to-face. What happens afterwards is that this PAR is pre-circulated for the 802 plenary, which is in July. And if everything goes as planned, the other working groups of 802 review, give comments, we update the PAR, and hopefully the PAR gets approved by 802, and then it gets on the agenda of the next IEEE Standard Association NESCOM meeting. If everything goes fine, it gets approved, we have an official project to run. And we can work officially in the project from the meeting onward, from the September interim and on TSM weekly calls. And we have various ballots, we can make those steps and so on, and we can done with the project 1.5 years is reasonable if everything is quite clear, or if it is a shorter project, it can be 1 year, depends on how the contributions, discussions, agreement, consensus building is done.
So just a quick question then on that one too, as a follow-up, sorry. So that means, that the timing would be like between now and like 1.5 to 2 years to come to something, correct?
So, Dorothy Stanley. So on the question of the timing, Janos described the process for launching the project officially. And given where we are now, in March, the official launch of the project would, the soonest that could happen is September. Given that, work in a study group can carry on starting now. The project would be officially started by IEEE in September at the September Standards Board teleconference sessions, and then work could continue. And then the project is authorized for 4 years. The progress of the work and the rate of the work depends on the topics and the participation level. So depending on the nature of the changes that need to be made, you could finish in 1 year, 1.5 years, 2 years, 3 years.
Yeah, but it's clear technical contribution can begin now and has already begun, I guess.
Keyur Patelarkas, at the risk of probably saying something wrong, but as we understand, Paul, you are the liaison between IEEE and Lsvr on what goes around between the two different bodies. It would be great if someone can start updating us with the status on IEEE so we could help contribute to whatever that is needed to the ecosystem and make sure we come up with the right solution from point to point periodically as there are progresses or updates done within IEEE, particularly for this set of topics.
I just want to clarify one point in the beginning, as you said, there is no liaison person typically. Like as Paul made it clear, he is an individual bringing the letter. But
so then that would be a note to the working group chairs to somehow set up a process. That way at least announcements would come, or if you suggest we should be doing it personally, let us know.
But it is an individual or contribution organization just like IETF, so there's nothing that prevents that from happening.
Understood, thanks.
Alberto, I was going to say the same thing. I'm also going to point out that Eric Ray, sitting over there, is the official IETF to IEEE 802.1 liaison. So the IAB does have a formal liaison program. Now, what that means is that there is that formal process of us sending liaisons and liaisons going back. If we have common participation on both sides, like what Paul has been doing, where he participates in the IETF, participates here, if we can have people from here participate in the IETF discussions, that would be the best thing, right? Because we don't have to rely on official things going back and forth.
Yeah.
John Messenger. I'm acting chair of 802.1. Just to clarify, our May interim meeting is in Salt Lake City from May 20th to 24th, and people will be very welcome to attend there. As Janos also mentioned, we do have TSN weekly calls that may well be able to be used for discussion of the technical requirements in this area. So we can begin to work on this in a fairly prompt manner.
Yeah, and just to add to that, I intend to ask for a time slot on a Monday call very soon, actually.
Yeah, we can arrange that. So I just want to emphasize it again, what has been said, that the technical discussion can happen from now on. This is kind of, if I would like to try to make an analogy. This is before an IETF analogy, like this is pre-part discussion in IEEE, kind of before working group adoption discussion in IETF. Similar, kind of similar stuff. So we can have the technical discussions ongoing now and officially with the project from September.
Yeah, there is a lot of discussion on the different processes between IETF and IEEE. They're not so different in many ways, and that is documented on the coordination website between the two organizations. And we have a lot of history of working together closely on various things, so there should be no barriers really in that process. Okay, so let me transition into discussion of kind of what I and a couple of others of us have been proposing. And again, it's very, there may be many changes that could be considered to this. This is nothing cast in concrete. I did an initial analysis of the ideas and how they might meet requirements from LSVR, and that's been presented previously. This was simply just looking at the list of information that is being exchanged in the LSOE messages today, and determining, well, could we put that in an LLDP v2 TLV? And clearly, many of the things like MAC addresses and IDs and attributes lists, we believe are very obvious that can be done. There was a question about the authentication data itself, like we don't know what the security proposal is and how big it is. Currently there is a limit to a TLV size in existing LLDP. That could be extended as one of the things of this project, for example. Obviously, encapsulation addresses, keep alives was one thing. So keep alives, again, there was sort of a desire for a 1 second type of link, liveness. LLDP wouldn't really work well unless we define something specific for keep alive. Today, you send the entire LLDP information when you send something, and so we wouldn't want to send in everything every 1 second. So something would need to be done for that. But again, we also felt there are other layer 2 liveness solutions that exist and are widely deployed as well. And then in terms of acknowledging information, that's an implicit part of this new proposal, because the main objective here is to send more than one PDU's worth of data. So in order to do that, you immediately bring in the need for acknowledgements and things. So that was a summary. Have a look at that, and provide me feedback or anything. That's fine.
AC Lindum, I don't know if you've looked at it, but we also before LSOE there's a draft that I wrote the bulk up to use LLDP. And one thing, we really need bigger TLPs because just there's the organizational specific for the IETF. You could fill that up very quickly, and it wouldn't really help you to have multiple PDUs unless you could. It would really be cumbersome if you don't make the TLVs bigger.
Okay.
Keyur Patel, Arcus. I'm talking about the same draft that AC is talking about, which I have co-authored. And really, there are numerous use cases that we want to go attack. And like AC said, for that, extending PDUs is one thing, but you really need other things as well to make that, which would fundamentally alter the protocol, and we should chat about that. Like I said, happy to contribute. But there are more than one use cases. Periodic refresh, eliminating them is one of them.
Right. So that sounds like an excellent topic for one of our phone calls. So maybe we'll get that on the agenda soon. Okay, again, I'll go briefly over a quick summary. Why were we doing this? Well, one of the main things was to send more than one PDU's worth of data, but there might be other things. As we know, LLDP is widely deployed, so it's likely to be there or remain running even if there is another protocol. So having multiple protocols doing very similar things could be not desirable. But again, we do need to meet all the different use cases. So, and again, the number of things that we keep sending in LLDP continues to grow. Every time we add a new standard protocol, we tend to add another TLV, and there's millions of vendor-specific TLVs out there as well. So, again, we've looked at motivations for people to do different proposals just because of this PDU size issue. Relying on jumbo frames is not a good solution, as we know. That's not very, it's difficult to deploy in all environments. So at a minimum, we need to exchange more than more TLVs, and LSVR requirements are just one example of that. We have many other examples. So no matter what, it's time to do something to LLDP, regardless of if it meets all of LSVR's needs or not. We're going to do something, I think. So it's a question of what we do. So the objectives were obviously to send more than one PDU worth of data, and we also had an objective to even shrink the PDU if we want to support some kind of smaller PDUs for our time synchronous environments, because we don't want to just blow out timing of other protocols that are mixed on the wire. So by shrinking the LLDP PDU, then we bring even more need for multiple PDUs. So that was something that came up through our TSN working group as an additional thing. And of course, one key objective that I'm pushing for strongly is the ability to communicate with existing LLDP that's out there. Obviously not all the extra data, but at least the first PDU's worth of data. A version 2 should be able to talk to a version 1 and get the exact same capability we have today. But if you do version 2, you get this extra capability. So that's an important aspect, I think, of our proposal here. We want to make sure that this works right, of course. And then there are other things that we can consider. If we're going to crack the book, let's look at other things like, maybe the rate at which we're doing updates. Maybe we should have new reachability. So LLDP doesn't just have to be link by link. We can put different addresses in the packet and have it go different reach across the topology. So one example might be define a new address called nearest router or something. And that might be very useful for clients discovering their gateways or all the gateways that are out there. So, there's I think some useful use cases there. And then finally, one I think which I just heard today was allowing a larger TLV itself. So rather than currently we're fixed at 511 bytes of information, making that larger, or some method of fragmenting or whatever would be needed to support that. So those are ideas. So just a quick reminder, how does it work? I think everybody's pretty familiar with this, but one simple concept that helps think about how this works is imagine that you have your own local database of information, and that database can fit in one packet. Well, anytime I change something in that database, what I do is I send it out to all my peers, and then they update their copy. And then if something changed, then they'll notify higher layer protocols that care about what's in that database. That's a very simple way to think about it. And then you just periodically refresh that information, and it's very simple and straightforward. So that obviously works really well when you have one packet, but when you have more than one packet, it changes quite a bit of the dynamics. So this slide's very hard to read, I know, but the idea was, this current idea, again, I want to keep emphasizing that, is that we would require a new TLV. So there's already a set of TLVs required in every packet that help you identify the peer. We would add an additional TLV that would be required if you were version 2, and that TLV is what we call an extension TLV, that basically something that defines all the other TLVs you might be sending. So sort of like checksums or something of each packet. And that'll be received by a version 1 implementation. So the way LLDP works, you'll receive that information. They won't know how to interpret it, but they'll still hold it in the MIB, and it's available. So it doesn't break anything. It's just opaque data to a version 1. But that new TLV would again define all the other extensions that I want to send. It would have some way of identifying each of those extensions so we could know that we've received them all. And again, it would be ignored by a current implementation. And then that new so then we would have new PDUs, extension PDUs, and those would have a different format. At least they would have something that makes them ignored again by a version 1. So we don't want a version 1 implementation to wipe out his database every time he gets an extra packet. So we would have it such a way that that frame was ignored. And there could be many ways to do that, the easiest of which is just to use a different ether type. And then when a version 2 person receives the main PDU that gives a description of all the other PDUs, if he doesn't know, he doesn't have those PDUs, he would send a request message. So he would send, hey, I'm missing the following information. Please send it back to me. So that's how you would get your database synced up, if you will. So there's a couple cool optimizations about that. Usually LLDP, once it's stable, nothing changes. You're just kind of refreshing in case up here popped up and he needs to hear about it, and you support shared media. Nothing really changes. It's just sort of going on. And so we don't have to send all the world's data every time. So with this new proposal, we would just send that first packet and be very compatible with existing implementations. And we could age things and stuff similarly. Currently, the number of extensions that we can send, extension PDUs, is limited by how we describe them. We're going to put in a TLV, we're going to describe all the other packets, so I can only describe so many. The current proposal is using like a 16-byte checksum. Maybe that's overkill. So that only allows like 31 packets. So it's not quite your 64K that LSVR has. I think it's about 45K. But again, that we can change that by shrinking the size of that checksum. Okay, so here's kind of the proposed operation of this proposal. So you imagine, you got two agents. This agent on the left, he has a local database. Let's imagine he updates something in his local database, and it expands multiple packets. As soon as he does that, he's going to send out the first TLV, the first packet, which is compatible with an old implementation, and then he's going to follow it with these existing packets. And so the receiver's going to coalesce those, get those, and when he's received everything and it all looks good, he's going to tell his higher layer protocol, just like he does today, hey, something changed in this database, go do what you need to do. So then let's assume that that agent, that this other agent hasn't been around before. Nothing's changed. He's going to send his first packet back that just says, here's a description of my database. If that person has never seen that before, or he doesn't have the accurate view of the database, then he's going to send what we call this request for extension. So he's going to request the missing packets. And then the other agent would just reply with those missing packets. Everything gets synced up, and again, we update the higher layer. So very simple augmentation of the current philosophical LLDP with this, just allowing additional packets. So that's kind of the high-level summary of how it works. Again, as we mentioned, we approved we approved to generate a project again and start working on this and deciding what the scope and requirements are. So great time to have input from LSVR. We have a design team of people that continue to look at this offline, so to speak, and like I said, Randy and others have in the past participated to that. And anyway, I have more details like, PDU formats and things like that are in the background of this slide deck, but I don't think we have time for that. It's probably not necessary. All right, so any questions about that?
Just for information, I want to come back with a clarification to an earlier point made in the very beginning at the chair's intro. Somebody said the person who wrote the liaison letter. The way it happens in 802.1 is not a person writes the letter, but the group. So actually, we sit in a room like here, it's on the screen, and we do the verse meeting like 60 people, 100 people in the room. So that's the group's message, not one person's. The other thing I thought it might be coming back. I heard that this point has been made before in this group, that actually it is not likely that it would be good for the industry to have two protocols for the same problem. It seems better for everyone to have a single standard, a single protocol. That's why we do standardization. So for link layer discovery, we already have a standard. And if we have two standards, then everybody has to implement two protocols. So it's not that good for the industry.
Keyur Patelarkas, let's get the requirements sorted out first. I think we can follow up with the solution later on. As long as the requirements match what we are after, I think the protocols can be worked out. But I can clearly see some of the requirements missing, so we should chat.
Okay, yeah, I'm happy to chat with you offline and happy to also coordinate with the TSN working group a phone conference where we can share that. Okay. All right, thanks.
Morning, folks. My name is Keyur Patel. I'm going to give an update on BGP SPF draft. So the draft itself was updated in December. We've got lots of comments from Eric Rosen, particularly focusing on the convergence aspect of the draft itself. The draft, we've incorporated a lot of those comments as well that we received. It's in a fairly stable state. We've also received lots and lots of reviews from folks that has been incorporated. Implementations are way under way to get it going. I know at least one implementation that got the SAFI up and running and SPF being calculated. We're going to start publishing some simulation results pretty quickly. The change with version 4 that came mainly was an addition of link NLRI attribute, BGP SPF status TLV that was added. This is to signal when the link goes down without immediately withdrawing the link NLRI itself. And this is to aid faster convergence when you have link outages. The similar kind of status TLV was added for prefix NLRI that would be applicable to the prefixes for that link that had gone down. And this is again to aid fast convergence. Aside from that, there's no more update. Questions? Comments?
So, the only comment that I have is that I would like to encourage the working group, again, to please have discussions on the list. Maybe we can get some more reviews, volunteer reviewers, etc., so that we have just more going on.
And to that point, specifically, if you're implementing and you have an implementation on the way, let us know. Would be happy to do some interop testing as well.
AC Linda, I wouldn't expect you to open source it, but one thing that I think they've done for Rift is they have a binary that people can test against. At least I didn't talk too much to them this time because it was against BFD and I need to be at the BFD working group, so I didn't hear. But I think that would be an alternative with your implementation, if you could somehow subset the product one into a binary that a person could start up.
Yeah, not a bad idea. I'm assuming you volunteered for that.
So here's a question to the group. Is we seem to have a draft here that's starting to get mature, or at least so we think. How many folks in the room have had an opportunity to read the latest version of this draft, or potentially maybe the penultimate version, the previous version, just as a show of hands? So we have a few. So what we'd probably want to do, as Alvaro mentioned, is we'll go to the list, and we would like probably some additional review. So we'll sort out how we can coax a few folks into doing kind of a detailed review. At this point, we want to make sure we got we kind of vet out any additional challenge, or if there's anything else that we have to resolve or deal with in the draft, we want to make sure we get that done. So we'll make that ask on the actual list itself, as well as to also have, like Alvaro mentioned, the comments. If there's questions, concerns, or things we need to address, we would really like to see that on the actual list itself. And even if folks had any sidebar conversations, please relay those onto the list so we can see what that is, and so we can effectively mature this out. So yeah, this is the last line. The other thing, Alvaro, I'm going to try to encapsulate the conversation we had. There was a lot of discussion around the liaison and working with people working back and forth. So we'll try to capture that just so we understand whom will be actually contributing with the folks over, like Paul and whatnot on the IEEE side. And we're going to try to sort out I heard a lot of discussion around the requirements. I want to understand with Gunter how we can make sure we get that pulled out and we really understand what that is. I heard it a few times. I didn't really hear a resolution on that just yet. So we'll come up with some ideas as to how to kind of get that resolved and then play that back. So there's clarity as to how we want to get that done. So we don't assume positions at that point. Is that fair with you? Oh, coming to the mic.
Sure, that works fine for me. As I said before, I think one of the best things that we can do here is to have that people cross-working in both organizations, not just depend on Paul to bring the messages back and forth or formal liaisons, but to have that interworking. Yes, would be great if we can have a list, a document, an email, something at least that we can point to and say these are the requirements specifically, so that we can share with everyone else at the same time.
Am I done?
Yeah, you're released to go.
Thank you so much.
Maybe I just thought to mention one of the recent examples about the good collaboration between the two organizations, IETF and 802. There was a project in 802 to specify extensions for VDP for NVO3. So the NVO3 working group and 802.1 has been working together to extend basically an 802.1 protocol for NVO3. So that is one of the recent examples of collaboration.
Thank you. Noted.
Yeah, I'm looking forward to working on this problem. I guess I just want to emphasize that it's hard to keep our eyes always on the customer and the end game here, but I mean, I think we want to do what's best for the industry, regardless of how things kind of come out. And just from a taxonomy kind of point of view, there could be obviously several things that could happen. We can look at a suite of protocols that 802.1 already has that meet the requirements. We could do a new project in 802.1 that tries to meet your requirements. We could do nothing and just let LSE go its own way and do all these are all options that are on the table. But I think it's really important that we keep an eye on, well, what's the most important thing for really the industry here? And we don't want to create a bunch of fragmentation and extra work on operators and everything too. So I think it's strongly important that as organizations we come together on this particular problem. So again, I'm willing and looking forward to that collaboration. So.
Rob Ostein, Arcus, just an architectural level, for whatever it's worth. The IETF has been down this road before in other protocol suites. For example, we have X509 versus DNSSEC, right? And really part of the issue in those cases is there enough that's different about the requirements for this protocol that it really needs to be a separate protocol? And that's why I think it's actually really important that we do the requirements analysis, because DNSSEC really did have special requirements, packet size, and just too much baggage. For other things, X509 is a pig, but it's a pig that works, so okay, whatever. And we just need to figure out whether or not this is special enough that it actually needs to be a different thing.
Yeah, I think that's precisely why getting the requirements teased out well is going to be really important for us to isolate, so we can make that determination correctly and have agreement as to what that is. So, thank you. Anything else? Okay, with that, unless there's any last comments, we would be adjourned with today's agenda. Okay, well, thank you very much.